Hey, you're welcome. Welcome to our next lesson on solving compound inequalities. Hope it's great weather wherever you're at, whether it's snowing, or raining, or whether the sun is shining. However, whatever's good weather to you, I hope you guys are having some good weather because fun weather makes fun days. Sometimes some of us don't think windy days are very fun, but if you're looking to fly a kite, there you go. You need a windy day. Like I said, solving compound inequalities. And we've already talked about what inequalities are. Inequalities are either less than, greater than, less than or equal to, or greater than or equal to. And now what's compound mean? Compound means, well, if you think about compound words, football. Football is the word foot and ball combined together for a compound word that are two words put together. Well, compound inequality means we take two inequalities and we put them together. Let's see what that looks like. On the left side here in green, we have two types of compound inequalities. One of them that has or, one of them that has and in between them. So the one here in green, the and, it says 0 is less than x, which is less than 8. 0 less than x, less than 8. That can also be written as 0 is less than x and x is less than 8. So we have two inequalities here. Do note that this one right here on the left, 0 less than x, can also be written as x is greater than 0. And this is the reason why, when working with compound inequalities, that you should be able to recognize that those two inequalities that the arrow is pointing at are exactly the same. Okay, so that is an inequality that represents and. And when we talk about this, we're talking about which numbers for x are going to be between 0 and 8, actually. That's what we're talking about. So like the number 1 fits because it's between 0 and 8. And number 2 fits because if we plug it in there, 0 is less than 2, which is less than 8. And basically, what, 3, 4, 5, 6, 7, all those fit. Now, those are whole numbers, but also like numbers like decimals fit. 2.22. And it's just basically any number in which 0 is less than x and x is less than 8. So that goes for basically an infinite amount of numbers that falls between 0 and 8. On the right side here, we're talking about or. Or means that we just have to, the number that we pick has to either fit this inequality or this inequality. So the number that we pick, or the number that we choose, the values, the solution set of numbers here, or x has to be less than -2, or x has to be greater than 4. So can you pick a number for me? Well, what about if we pick -10? Well, -10 less than -2 or -10 greater than 4. Is this true? -10 is less than -2. That one is true. Or -10 is greater than 4. That's not true. But because this is an or, all you have to do is meet one of them in order for the solution to fit. Let's say we pick 0. 0 less than -2 or 0 greater than 4. 0 less than -2? No, it's not. Is 0 greater than 4? No, it's not. So neither one of these are the answer, so 0 is not an answer to this compound inequality. So when we look here, which numbers are going to be answers, or which numbers are going to be solutions to this compound inequality and which ones won't. Well, it's going to be the numbers that won't will be between -2 and 4. Any other numbers will be a solution. Any numbers that are less than -2 will be a solution, or any numbers that are greater than -4 will be a solution. Okay, well, since we have that done, we can move on, and we can talk about a couple real life situations here. Old Jackie Jack, he's on the high school wrestling team, and it's important if you're on the high school wrestling team to watch your weight, because there are weight classes that you can wrestle in, and if you go above your weight class, you have to move up to the larger weight class, and if you move up to the larger weight class, you're usually wrestling bigger guys, and so when you're a wrestler, you try and maintain your weight. If not, you try and lose a little bit of weight. There are regulations on how much weight you can lose, but let's figure out what Jack has to do here. He's on the high school wrestling team. He currently is 138 pounds, and he's wrestling in the 140-pound weight class. Well, 138 pounds is less than 140, so he's able to wrestle in that 140-pound weight class. In order to stay in this weight class, his weight cannot exceed 140 pounds, and it cannot drop below 135 pounds. The weight class, 135 pounds is the weight class below 140 pounds. So it looks like whatever state he's wrestling in, they have a 135-pound weight class, and then they have a 140-pound weight class. And Jack right now is in this one, and he wants to stay in this weight class. Maybe he's going to stay in this weight class because nobody else is in this weight class, and if he moves down or moves up a weight class, then his team will have to take a forfeit, and they give when they take a forfeit, they give a certain amount of points to the other team, maybe like 6 points, 6 or 8 points. It depends on, I guess, where you're at. I think mostly it's 6. Well, so let's figure out what we got to do here. Write a compound inequality to show the weights that Jack has to be this wrestling season. All right, well, this is where he's at right now. This is where Jack is at right now. He's at 140. So how do we write this compound inequality? Well, his weight, it doesn't tell us which variable we're going to use for weight, so let's use the variable W. His weight has to be greater than which number, 135 or 140? If he wants to stay in the 140 weight class, he's got to be greater than 135 pounds. But his weight also has to be less than, well, if he's got to be greater than 135, he's got to be less than 140. So he's kind of got to be between 135 and 140. And how do we write this out? Well, you can write it out like that, but you have to put the word "and" here, because he has to his weight has to fall greater than 135, or it has to fall less than 140. That's what his weight has to be. Now remember, this one here on the left, we could rewrite this to say 135 is less than Jack's weight. And then we can also take this one here, his weight, W, is less than 140. And that's how we write it in a compound inequality. Either one's fine. Number 1 or number 2. Either way will represent this compound inequality. For number 1, make sure you have the word "and" in there. Look at this situation. Susan needs to speak with her daughter, so she sent her a message to call her. It doesn't look like it's real important, because Susan didn't say that she needed to urgently speak with her. So Susan just needs to speak with her daughter. Maybe she needs to figure out what they're doing for dinner tonight. whether they're going to the little Italian shop down the road or they're going to the steakhouse across town. Who knows? They might just skip dinner and go to the ice cream shop, get a hot fudge sundae with the cherry on top, maybe some sprinkles, maybe some nuts. Well, I think we all know what we're doing after the video, right? Well, let's get this. Let's get through this then. That way we can go get us a hot fudge sundae. In the message, Susan told her daughter that she has a meeting from 1 until 3 p.m. So we need to write a compound inequality that represents the time in which Susan's daughter can call her. In which Susan's daughter can call. So what times can Susan's daughter call and reach Susan or reach her mother? Well, if Susan's got a meeting between 1 and 3, she cannot call between 1 and 3, right? So, so Susan's daughter has to call before the start time of 1. So how do we say that? We're going to use the variable t, right, for time. The time in which Susan's daughter can call has to be less than 1 p.m. Wait a minute. She has a meeting from 1 until 3. So could she call after 3? Yeah, because Susan's still going to be at work. Susan's probably not getting off work until after 3 o'clock. So the time in which she can call can be after 3 o'clock. Now we need to figure out, is this going to be an and compound inequality or an or compound inequality? Does Susan's daughter have to call between 1 and 3, or does she have to call before 1 or after 3 o'clock? She's going to have to call before 1 o'clock, or she's going to have to call after 3 o'clock. So when you write this compound inequality, you write it like this, with an or in between it. Let's move on. Let's move on to writing compound inequalities given this situation here. It says write an inequality that represents the set of numbers and graph the inequality. Okay, so write an inequality that represents the set of numbers. First off, it's going to be all real numbers. Whenever you see this, all real numbers, you just think of a variable. That's going to represent a variable. It represents a set of numbers, so it's going to, all real numbers is going to be the set of numbers that are less than 6 and at least 4. So all real numbers less than 6. We put a less than 6 there. X, blip, 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 blip. Yep, that's what I thought too. X is going to be less than 6 and has to be at least -4. Well, and X has to be at least -4. So if we think about this, if a number is at least -4, that means the smallest that this number can be will be -4. But it still has to be greater than -4. But could it be -4? The smallest that it can be is -4. So we put the equal to sign because X can be equal to -4, but it has to be at least -4. So that's where the greater than symbol comes into play, because the real number X has to be greater than or equal to -4 in order for it to fit the at least -4 part. Since this is an and compound inequality, we know we can write these inequalities together. X goes in the middle. This left one, X is less than 6, so we're going to put less than 6 here. And let's look at the right one. If x is greater than or equal to negative 4, we can flip this around to say negative 4 is less than or equal to x. And then this is what we shift over into our compound inequality here. Negative 4 is less than or equal to x. So either way is fine. You should start using this compound inequality, the and compound inequality put together like that, because you'll see that quite a bit. So how do we graph this? Well, when you graph this, you have to graph, you kind of got to look up here. You can either look here and here, or you can just look right here in the box. It depends on how you're able to do it. If you can see in the box and you can graph that, then that's good. And just focus on that and graph it from there. If you need to split it apart and look at these here, go ahead and do that for the first part, and then once you start getting the hang of it, you should be able to see what's in the box and graph it from there. All right, so the first one here, x is less than 6. X is less than 6. So let's go ahead and get some numbers on our number line. 0, 2, 4, 6. So for x is less than 6, is it open or a closed circle? Open. And which way is our arrows going to point? Well, let's pick test points. I'm picking 10 on the right side, and I'm going to pick 0 on the left side. Which one is true? Is 10 less than 6? No. Is 0 less than 6? Yes. So we know our arrow is going to point towards the left. On the right side here, on the right side, we have x is greater than or equal to negative 4. Open or closed circle? What'd you say? Yeah. Yep, closed circle. Because it has the equal to sign with it. That's why it's closed. Now let's pick a test point. Pick a point on the left. I'm picking negative 10. Pick a point on the right. I'm going to pick 0. Is negative 10 greater than or equal to negative 4? No. Negative 10 is not. Is 0 greater than or equal to negative 4? Yes, it is. So the arrow points towards 0. Now, you're not quite finished here, because what this inequality, what this graph of this inequality is going to show us is that the answers fall between, can you see that? The answers fall between negative 4 and 6. And on the left side there, negative 4 is one of the answers, but on the right side, 6 is not an answer. 6 will not fall into that compound inequality that we've started out with. It will not be a solution. So the solution set of numbers, that is the answer, negative 4 is less than or equal to x, which is less than 6. And you can see that there on the graph. Number 6 here, why don't you go ahead and take a moment, see if you can write the compound inequality. And see if you can write the compound inequality for that. I will write it down for you, and then if you need help graphing, you go ahead and wait, and I'll graph it for you, help you out with that. If you don't need help, then then you can check your solution. This says all real numbers that are greater than 2. So you say x is greater than 2, or all real numbers that are less than 1. Yeah. This is an or, so you cannot put those together like we did with the and. So let's go ahead and graph this here. We're going to start out with 0, 2, 4, and we'll put a -2 there. Let's graph this one. X is greater than 2. X is greater than 2. Open circle. Pick points. I'm going to pick 4 on the right side, and I'm going to pick 0 on the left side. Which one is true? 4 greater than 2? Yeah, I think so. And 0 greater than 2? No, it's not. So 4 is a solution, so it points this way. And the one on the right, x is less than 1, open circle at 1, and pick test points. Picking 4 and 0 again, except we're using 1 in this one. So 4 less than 1? Nope. Is 0 less than 1? Yep. And that's where we're at. And that's what your graph looks like. The solution set of numbers is going to be anything that is above 2. Let me get a different marker here to try and show you that. Solution set of numbers is going to be anything that's above 2, but 2 is not included in that answer. Or it's going to be anything that is less than 1. And remember, 1 is not included in that answer. And that's why those are open circles at 1 and 2, because they are not included in the answer. Well, how do we solve them? If we look at this one, we should know this is an and. The and compound inequality will look like this, or we'll always have an or with it. So if we look here, how do we solve this inequality and graph it? Well, it's not much different than what you've done before. Basically, you just have 2 problems there, and you have to solve each problem. And for the and one, you can do them separately, or you can do them together. Let me show you both methods, and you're going to understand that they're both pretty much the same. First off, this is what we have: 7 less than 4 plus x. Secondly, we have 4 plus x is less than 12. All right, so what do we do here? Let's work on the left side. 7 is less than 4 plus x. How do we get x by itself? Subtract 4. And that's what we have. 3 is less than x. On the right side, how do we get x by itself? We subtract 4. Subtract 4? Isn't that what we just did over here on the left side? We did the same exact thing. So x is less than 8. And if we notice, we could put these together. 3 is less than x, but on the right side, x is less than 8. That's one way to do it. That's one way to do it. The other way to do it is for you to understand what's going on here and to realize that we have 2 problems in this. 7 is less than 4 plus x, and the other problem, 4 plus x, is less than 12. We have 2 inequalities there, and we have to solve both of them. Now, the previous problem, I separated them, or the previous solution to this, I separated them, and then I worked them out separately, and then at the end we put them together. This one right here, we're going to keep them together, and we're going to solve them together. And then in the end, they'll already be together. Whichever way you're comfortable with working with is okay with doing. You'll still get the same answer in the end. All right, so we're looking here. What are we looking at? Well, if we're still trying to get x by itself. What is right there? What is right there with x? Well, that positive 4, right? Well, I have to subtract 4 from it. Now, if I subtract 4, I have to subtract 4 from both sides of the inequality. Now, that's if I'm working with the left inequality. But if I'm working with the right inequality, 4 plus x is less than 12, I have to subtract 4 from that also. So 7 minus 3 will give us 3. 4 minus 4 cancels. We're left with x, and we're left with 8. 12 minus 4 is 8. The inequalities will drop down. And if you notice, that is the same answer that we got when we split them apart. We have the same answer. You just have to make sure that if you subtract 4 from x, you have to subtract 4 from both problems, both inequalities. That's the part you just have to recognize. You have two problems here. How do we graph this? Let's graph the first one there. 3 is less than x. Open circle at 3. Pick some test points. 3 is less than 2. 3 is less than 4. Which test point works? 3 is less than 4. Yep. So it points towards the 4. So we'll think about that there. I'm not going to put any arrows on that because I know that with x is less than 8, we're going to have an open circle at 8. And pick some test points. 6 less than 8. And let's go with 10. 10 is less than 8. 10 is not less than 8, so that's not our answer. 6 is a solution, so our arrow points towards 6. And if we look, the arrows will be overlapping right here. The arrow from the 8 still keeps on going. The arrow from the 8 still keeps on going clear out here. And the arrow from the 3 still keeps on going clear out here. But which numbers satisfy the inequality right there for x that makes that inequality true? Well, it's all of these numbers. Green's probably not a good choice on a green number line. It's all of these numbers right here between 3 and 8, but 3 and 8 are not part of the solutions. Do we know why 3 and 8 is not part of the solution? If we use 3, 7 is less than 4 plus 3. 7 is less than 7. Nope, 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 nope. 7 is not less than 7. Not true. If we use 8, 4 plus 8 is less than 12. 4 plus 8 is 12, which is less than... No, it's not. Cannot be that. And that's the reason why 3 and 8 have open circles, because that's not true. All right, let's move on. We got a problem here. If you need to, you can separate this into two problems. I'm not going to do that. I'm going to leave it as one problem here. Let's go ahead and work this out here. So how are we going to get k by itself? Well, if we look, we have to subtract 3. And if we subtracted 3, if we're talking about this inequality, if we subtracted 3 on the left side of that inequality, we have to subtract 3 on the right side of that inequality. Now, remember, if we subtracted 3 on the right side of this inequality, we have to subtract 3 on the left side of that inequality. So let's go ahead and work this out. -1 minus 3, -4. Drop down our less than symbol. We drop down -2k. And 3 minus 3, those cancel out. Bring down our inequality, less than or equal to. And 13 minus 3 is a 10. K is not by itself yet. We still have that -2 with it. And when you think that you're going to divide this by -2, you should have a little ringer that goes off in your head that says, ring, ring. No, not that one. That sounds like a phone ringing. We don't need that kind of ringer because you might try and answer your phone. Well, okay, let's try this again. When you divide both sides, or when you're dividing an inequality by a negative number, or -2, negative number more specifically, you should be thinking it has this ringer going on. Ring, 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 ring. There you go. And then that's caught your attention. So inequalities, dividing or multiplying both sides by a negative number, you got to catch your attention. Because, well, let me go ahead and just do the work here. We divided everything by -2. -4 divided by -2, remember, negative divided by negative is a positive, 4 divided by 2 is 2. Now look at this inequality. If we divided both sides by a negative number, the inequality gets flipped. That's what that ring was about. Okay, -2's cancel. We're left with k. Once again, another inequality. Flip it. And 10 divided by -2 is -5. All right, so let's go ahead and see what we can do here. Let's say we have -6, -4, -2, 0, 2, 4, 6. All right, let's graph this inequality on the left side. 2 is greater than k. Open or close circle at 2? Open. 2 is greater than k. Now, 2 is greater than k. Pick a number. Here's a test point. Pick a number on the right side. What number do you want to pick? Which number? Okay. Yes. Yeah, we'll go with 10. It's on the right side of 2. And pick a number on the left side. Number? We can go with 1, but 1 doesn't go there. 1's going to go in place of k. So it says 2 is greater than 1. 2 is greater than k. Okie dokie. Which one is true? 2 is greater than 10? I don't think so. 2 is greater than 1. Yes, that's true. So it's going to point towards the 1. I know this is an and compound inequality because it's grouped together like that. It's put together like that. So I'm not going to put an arrow on the end of this because I know that it's meeting up somewhere. Probably there with that -5. So now let's graph the one on the right. K is greater than or equal to -5. Open or close circle at -5? I'm sure you got your answer. It's going to be closed. It's going to be closed because of this equal to part of the inequality. So we're looking here. K is greater than or equal to -5. Well, we're looking at -5. Pick a number to the left. -6 is greater than -5. Here's our inequality. K is greater than or equal to -5. And pick a number on the right. We can pick any number. I'm choosing -2. So -6 is greater than or equal to -5, or -2 is greater than or equal to -5. It's not that one. And so our arrow should be pointing towards -2. And if we look, since this is an and problem, it's where these two inequalities will be overlapping, and they are overlapping right there. Yeah, any thoughts? No thoughts? Nobody has any questions? Okay, all right, good then. Let's look at the next one. The next one says or. Like that. That's kind of cool. All right, let's get back to our compound inequalities here. Or, well, when we see or, we know that our solution set only has to really make one of these inequalities true. Okay, so let's start here. In order to solve these compound inequalities, it's the same as an and. Remember, we have two problems, and we just have to get t by itself. These, when you have an or compound inequality, they will not have the same steps. Like in the and compound inequality, I don't remember what we did over here. We subtracted 3 in both of them, and then we divided by -2 in both of them. But in this one, we won't always have the same steps. I know if we look here, our first step is to add 1, and this one here, it's still to add 1. But our next step isn't going to be the same. Those cancel, so we have 4t is greater than 8, or 5t is less than -5. And see, this is where it's different. Our next step is to divide by 4, divide by 4. T is greater than 2. The 4 is canceled. Or divide by 5, divide by 5. 5 is canceled. T is less than, what's -5 divided by 5? -1. Did you notice your ringer didn't go off on this one? Because we divided by both sides by a +5. I know the 5 on top was negative, but it's what you divide both sides by, and we divided both sides by a +5. So this line right here tells us our solution set. T has to be greater than 2, or T has to be less than -1. Let's go ahead and get some numbers down. So what are we looking at? 1 on the left. T is greater than 2. T is greater than 2. Open circle at 2. Pick some test points. 4 is on the right side. What number is on the left side? We can go 1. 4 is greater than 2? Yes. 1 is greater than 2? No. So it's going to be pointing towards the 4. I know this is an OR problem, so they should be pointing in opposite directions. T is less than -1, so open circle? Yes, open circle at -1. Pick some test points. 0 is on the right. What number is on the left? You can pick any number. I picked -4. 0 is less than -1? No. -4 is less than -1. Yeah. You got it. -4 is less than -1. So therefore, there we go. The arrow points towards -4, and all the numbers that are going to be less than -1 is the way the arrow is pointing. And so you have your graph there. And you should see that any number that's greater than 2, but not including 2, and any number that's less than 1, but not including, or I'm sorry, not less than 1, but less than -1, but not including -1, are your solutions. So T is greater than 2, or T is less than -1. I think you can go ahead and do this one on your own. Don't forget that little ringer inside your head. You should be paying attention, because it just might ring and catch you off guard here. So you should always pay attention. When you multiply or divide both sides by a negative number, that ringer should be going off. So let's go ahead and see what you can do. Pause the video, and then I will work the solution out here in 1 second. All right, on the left side, subtract 3 from both sides. 2y, cross those out, is less than -1 minus 3. -1 minus 3, -4. Divide both sides by 2. Cancel. Y is less than -2. There you go. It's almost a Yahtzee right there. Got 4 5s. I'm looking for one more. I'm talking about Yahtzee, not math. I'm talking 4 5s. what are we looking at? Let's go ahead and do it in a different color here for you. Trying to get y by itself, so we add 5, negative 3y, the 5's canceled, is less than or equal to negative 2 plus 5, negative 2 plus 5, what is it? It's 3. Yes. Divide by negative, ring, ring, ring. Hello? Hello? Oh, hi, Grandma. How are you doing? Oh, I'm just teaching a lesson here. Can I give you a call back? Okay, I'll call you back here in a lesson, in a minute, as soon as the lesson's over. All right. Bye. Ring, 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 ring. There's your ringer you're looking for. It's ringing. Look at this. Negative. You're dividing both sides by a negative. You got to get it. Okay. Negative 3's cancel. We're left with y. What happens to the inequality? Did you do it? Did you fix it? Did you flip it? I hope you did. I hope your ringer works. All right. Y is greater than 3 divided by negative 3, negative 1. Okay, well, let's see what we can do on the graph. 1 on the left, y is less than negative 2. Well, we should probably get some numbers on here, right? Y is less than negative 2, open circle. We've had a lot of open circles. Oh, we're going to get a closed circle on the other one. It's going to be an open circle. So y is less than negative 2. Pick a number on the right. 0. Pick a number on the left. And that's on the right of negative 2, on the left of negative 2. Okay, 0 less than negative 2? I don't think so. I don't think so. There you go. So the arrow is going to point towards negative 4. Okay, on the right side, this is what we have. Y is greater than or equal to negative 1. Open circle at negative. Whoa. Looky there. We have an equal to sign. Greater than or equal to, which means that we close the dot. Okay, so y is greater than or equal to negative 1. Let's pick a number to the right of the negative 1. Number to the right. Pick a number to the left. Which one's true? 0 greater than or equal to negative 1? Negative 2 greater than or equal to negative 1? It would be 0. So the arrow points towards 0. And there would be the graph of your solution. Here is your solution set written out using inequality symbols, and then your graph, of course, is down there at the very bottom, your number line. Okay. Looks like we got a couple more examples, just 2 more examples here. This one's for you to do on your own, and then check your solution. So go ahead and do this one on your own, and then check your solution. I hope your ringer's working. All right, so what are we going to do here? Let's say we need to get n by itself, so we add 7 to both sides of the left inequality. We added 7 to both sides of that inequality. And then we're going to add 7 to both sides of this inequality. 4 plus 7 is 11. Less than or equal to. 7's cancel. Look at that. What is that number there? Negative n. Less than or equal to. 8 plus 7 is 15. All right, so we're cruising along here. Let's make sure your ringer works when you did this one. My ringer is working. Can you hear it? No, it's because I can hear it. You can't hear my ringer working. All right, so we have negative 11. Ringer's going off to switch the inequality. Ringer's going off to switch the inequality. And this is what we have. That would be our solution set. Negative 11 is greater than or equal to n, which is greater than or equal to negative 15. Remember, you can also read that backwards from the way we have it written. Negative 15 is less than or equal to n, which is less than or equal to negative 11. Let's go ahead and get this on the graph here. Let's say that's negative 14, so then that's negative 16. If that one's negative 16, that one's negative 14, that must be negative 12. If that one's negative 12, and that one's negative 14, that one must be negative 10. If that one's negative 12, that one's negative 10, this one must be negative 8. If that one's negative 12, that one's negative 10, that one's negative 8, this one must be... we've got enough. We don't need to put that one down. All right, so let's look here. Let's do the one on the left. Negative 11 is greater than or equal to n. So we know negative 11 is going to have a closed dot. Negative 11 greater than or equal to n. Pick a point on the left. Negative 20. Pick a point on the right. 100. I said you can pick any number. Doesn't matter which one you pick. It doesn't have to be shown on the number line. We know 100 is to the right of negative 11. Which one is true? Negative 11 is greater than negative 20, or negative 11 is greater than 100? Well, if you believe that negative 11 is greater than 100, you should come and see me, because I got some oceanfront property in Arizona for sale. For sale on oceanfront property, Arizona. You come see me. That one right there is true. Negative 11 is greater than or equal to negative 20. So I know this is an and problem, so I'm not going to get too carried away with my arrow here. Let's do the second one. N greater than or equal to negative 15. That's a little negative sign. There we go. Open or close circle at negative 15. I believe it's going to be closed because it has that or equal to part. Now, which one are we going to have? Pick a number to the left of that dot, the dot we just put on there. We can pick negative 20. Negative 20 is less than or equal to negative 15. And then also to the right of negative 15, we can pick any number we want. Let's go ahead and take negative 10. Okay, so which one is true? Negative 20 is greater than or equal to negative 15, or negative 10 is greater than or equal to negative 15. Negative 10, that one's greater than or equal to negative 15. So our arrow must point towards negative 10, and we shade between those 2 points. Let's go to the next one. This is an OR problem. Let's see you go ahead and solve this one out. Pause the video, turn your ringer on. Actually, your ringer should always be on, so just make sure you're using it. Divide both sides by negative 2. We have an inequality dividing by negative. Flip the inequality. The inequality on the right, we're going to add 1. Nope. What'd you tell me that for? You know we're not supposed to add 1. Subtract 1. So we're left with 2x. The 1's cancel. Greater than 4. Divide both sides by 2. X is, we divided both sides by positive numbers, so the inequality stays the same. X is greater than 2. X is less than or equal to negative 4, or X is greater than 2. Let's graph the one on the left. Graph the one on the left. X is less than or equal to negative 4. Close the circle at negative 4. Pick point on the left. Pick a point on the right. Which one is true? Negative 6 is less than or equal to negative 4. So we darken that. Put the arrow there. The one here on the right, x is greater than 2. It's the open circle. Pick a number on the right. Pick a number on the left. Which one is true? It's going to point towards the 4. Make it nice and shaded there. And so that's what we have. So we have the graph, we have the solution set of numbers, and we're good to go there. Compound inequalities. Compound inequalities. Hey, let's not always remember, make sure your ringer's on for those negative numbers. When you multiply or divide both sides of an inequality by a negative number, turn your ringer on. And make sure it's always on. Make sure you're always aware of it ringing. Make sure you can tell the difference between that ringing and when your grandma's calling, or friend, or whoever it is. So, well, I got a hot fun Sunday to get to, and I got to give my grandma a call back so we can talk about whatever it is she wanted to give me a call for. Well, you guys have a good evening or a good day, or whatever time it is. I will see you. Well, I guess you never see me, but I'll see you the next time you show up. Have a good day.